Hello everyone, in this video we'll be solving problem 22, generate parentheses. The problem statement is, given an n pairs of parentheses, we need to write a function that generates all combinations of a well-formed parentheses. When we say well-formed, it should have an open and a closing parenthesis. In example number 1, where n is given as 3, we can build a total of 5 unique combinations. I hope you were able to understand the problem statement. This is a classic example where we can use backtracking to solve this problem. Now let's switch to whiteboard and discuss the solution. With n given as 3, so the total number of characters in the output string should be n into 2. As we need total of n pairs, so the size should be n into 2. So in this case, it will be 6. As we need to generate different combinations of parentheses, we can use the backtracking approach where we'll start adding the open and the closing parentheses in different sequence until the size of the string is equal to 6. And that's when we'll stop the iteration and record the output that we have generated in a collection. If I try to build the tree to simulate how will it look like, the root of the tree will always be an open parenthesis. There's no point in starting it with the closing parenthesis because it will be invalid. Now we have two choices here. We can either have an open parenthesis again right after that, or we can close it. So at this point, string should have two open parentheses, and on the right hand side, it should have one open and one closing parenthesis. As you can see, both are unique combinations. Now if we want to go deeper, on the left hand side, there are two possibilities again. We can have one more open or we can have a closing parenthesis. Just like before, if you look at the string at this point, it should have three open parentheses. And on the right hand side, it should have two parentheses which are open and one will be closing. And while building the tree, we'll record the total number of open and the closing parentheses that we are adding. This information will help us know when to stop the iteration, as we don't want more than n open or n closing parentheses in the string. If we continue any further, the output will be invalid as it will have more than n pairs. And just like what we did on the left hand side of the tree, we need to repeat the same cycle for the right hand side. And once the total number of open and the closing parentheses are equal to n, we'll save the string in the output collection and try a different combination. And once we have iterated through all of the combinations, the results will be saved in the output collection, which will be returned at the end. The time complexity of this solution is O of 4 raised to power n, as we are running recursive loops and doing a backtracking to make sure we are able to calculate all the combinations, while the space complexity is O of n, as at any given point of time, we are only maintaining one string with all of the combination that we have built so far. And the length of that string will not be greater than 2n, which can be simplified as O of n. I hope you are able to understand this explanation. Let me show you how we can implement this using C#. Here is my C# solution. In the main method, I start by initializing my results variable, which will hold all of the combinations, and then using a string builder, which will help me build the strings over time while appending the open or the closing parentheses. And then calling this backtrack method, which will help me iterate through all the combinations. In this backtrack method, I'm first checking if the length of the current string, which is the string builder, is equals to twice of maximum, which is n. If the condition matches, it means we have done all possible combinations without going beyond the limit that is given to us in the input. So we add the current into this results variable and return. If the condition do not match, then I'm checking if the total number of open parentheses is less than maximum. As we discussed earlier, we'll be using the total number of open and the closing parentheses to determine how many more parentheses we need to add to the string. The total number of open and the closing parentheses should not be greater than maximum, that is n. If it is less than maximum, then we append it to the current and then call the backtrack method recursively. Once the recursive call is complete, I'm removing the last element that was added from the current string. After that, we repeat the same operation, but this time we are using the closing parenthesis counter. So we'll check if the total number of closing parentheses are less than open, and if the condition matches, then we'll go ahead and add it to the current and then call the backtrack method recursively. Once all of the recursion calls are complete, all of the combinations will be saved in the results variable, which is being returned from the main method. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and 44% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.